Hi, I'm Sigrid Close, Assistant Professor at Stanford University, and this is STEMClass.
Science, technology, engineering, mathematics. STEMClass. The search for ET is on. Somewhere out there among the stars, it's very likely that there are planets that look a lot like the Earth. The Kepler mission has been launched and is looking for planets in a habitable orbit right now.
Incredible experience. Amazing.
The Kepler spacecraft follows right behind the Earth and stays pointed at an area in the sky that NASA scientists are interested in. They are looking for stars that appear to be winking at us. When a planet gets between the Earth and the Sun, or another star, the movement across the face of the Sun is called a transit. Mercury and Venus pass between the Earth and the Sun regularly. The Earth circles the Sun in a green zone, where water can exist in a liquid form. This is sometimes called the Goldilocks zone. Not too hot, not too cold. Around a hotter star, the green zone is bigger and extends further away from the star. Around a cooler star, the green zone is smaller and closer in. The size of the habitable zone around any single star depends on the temperature of the star. Hotter stars, bigger habitable zones. Medium stars like the Sun, habitable zones like ours. And around cooler stars, a smaller habitable zone. The scientists call these Goldilocks areas habitable zones. Look it up. Kepler is not a telescope. It doesn't take amazing pictures like the Hubble Space Telescope does. Kepler is a photometer. Photo means light, and meter means to measure. Photometer. Look it up. For Kepler, the stars don't twinkle through the atmosphere because there is no atmosphere in space. If a star has a planet circling it, the star seems to wink at us as the transits occur. The Kepler mission is all about finding transits. Kepler's mission is to look at a selection of stars for more than 3 years. The field of view covers 6 million stars, but Kepler doesn't want to look at all of them. Field of view. Look it up. When Kepler sees a star that is winking at us, it measures the dip in brightness and how long the planet takes to transit the star. When Kepler sees a star wink, it relays this information back to the scientists on the ground. When Kepler spots a transit, it sends this wink in the form of digital data down to the scientists on Earth. The data that Kepler sends back will tell us how big the planet is, how fast it is moving, and whether it is orbiting in a habitable zone. About once in every 100 stars, it does find a planet that is transiting that star. The planets are hard to see, right next to the extra bright light of the star. When the planet crosses in front of the star, the brightness goes down just a little. Kepler can tell a lot about the planet from this little wink. Because sunspots can have the same dimming effect, Kepler has to see 3 dips in brightness before it registers a hit. 3 winks and we have 3 transits, and some real evidence that there is a planet circling the star. What will we find when we spot an Earth-like planet in a habitable zone? Perhaps a planet suitable for life. Could it have advanced life forms living on it? No one knows, but the scientists at NASA are looking.
Ah, aliens!
The Kepler mission is all about finding transits. Next time, STEM class looks at the latest from the fourth planet from the Sun, Mars.
I'm Sigrid Close, and you've been watching STEMClass.